Good morning, everyone. I'm Siva Radhakrishnan. I'm a principal engineer here at Forward Network. For the purpose of this talk today, I'm going to be playing the role of a network operator at Vandelay Industries. So my organization runs a large network with thousands of devices, and we have a small network team that manages this entire network. So starting the week off on Monday, I received a support ticket from our server security team. So our security team identified that there was some suspicious looking SSH access in the network. So they periodically run scans of different logs from the servers and so on. And they had identified that there was a potential network security incident last week on the 5th of February. So they have this, so there's this application front-end server to which they noticed some suspicious looking SSH access. So they knew the IP address of the front-end server, and from the logs, they also knew where this SSH connection originated, what was the source IP address. And to help them with the investigation, they wanted to understand a few things about the network, how the network was configured, what was going on in the network, and that's why they reached out to the network team and created the support ticket. All right, so let's look at what the security team actually wanted to find out. So the first thing is, they wanted to know where did this SSH connection originate. They had the source IP address of the traffic from the logs, but they tried to ping this particular IP address, and it was actually unreachable. They just tried to ping it yesterday, and it was no longer reachable. So they had no idea where was this host even located in the network. So the next thing they wanted to know is, why did firewalls not block this traffic that they actually didn't expect to see in the network? Right? So they believe that this front-end server should only be accessible from a specific set of IP addresses. So why was this not blocked? Why did this traffic get through to the destination? And thirdly, they wanted to know that suppose an SSH key was compromised or an attacker was able to actually log into this front-end server, what are the other servers in this network that the attacker could have SSH to from the front-end server? Right? So the attacker is already on the front-end server. What are the other hosts that are potentially vulnerable and something that the attacker could have actually logged into? All of these seem like pretty reasonable questions, but how do I actually go about getting answers to these? So with traditional tools at my disposal, I might have access to some network architecture diagrams. So we have a large network with thousands of devices, so I probably have like dozens of different architecture diagrams. And as you all know, we all know how up-to-date those stay, right? Our network is constantly evolving. Our architecture diagrams are always up-to-date. They're always lagging behind. And in addition to the architecture diagrams, I might also have access to the configuration files. Obviously, I can log into these boxes. I know what the configuration looks like right now. But if my organization is a little more sophisticated, I might also have archives of configuration files from all the firewalls, say these were taken every day. Right? But in addition, I might also have the configuration files from all of the routers, load balancers, firewalls in the entire network. But a single configuration file on a particular firewall can easily run into tens of thousands of lines. And for my massive network, how am I actually going to make sense of all of this data? I have access to a lot of data, but how am I going to pour through all of this data and actually make sense of this? How do I figure out where is the source IP address? And even if I figured that out, how does traffic flow from the source IP address to the destination, looking at all these configuration files? Further, if I identify the firewalls, how do I know which firewalls are involved? And what are the specific lines of configuration in those firewalls that are actually relevant to this problem at hand? Right? It's like looking for a needle in a haystack. So there's a lot of data to comb through, and there's got to be a better way to do this. Right? So this is a task that looks like it can easily take me all day, if not the whole week. And it's just Monday. There has to be a better way to do this. Let's see how modern enterprise software can help simplify my life and help me get answers to these questions in just a few minutes. So here's what I'd see as a user of Forward Networks when I log into the platform. There's a modern browser-based web UI that shows me what my network looks like. I had added a set of devices to the Forward platform and configured credentials to access these devices. The platform periodically reaches out to all these devices in the network and maps out the entire network. So my entire team has an up-to-date view of what my network actually looks like. So what you see here is a small portion of Vandelay's large network. And this is what we'll be using today for the demo. Let's take a quick overview of this portion of the network that we're looking at. So what you see here on the bottom left is our Atlanta data center. On the right, you see our San Jose data center. So these two sites are connected by our MPLS transport network. And on top here, we see our AWS VPC. So this includes essentially our cloud infrastructure. And as you can see in this network, there's a pretty heterogeneous mix of devices. So we have load balancers, firewalls, routers, access switches, and so on. And there's a broad variety of different network vendors that are actually in this network. So we've got Cisco, Juniper, Palo Alto, F5, Arista, and I'm not an expert on any, I can't say that I'm actually an expert on all of these different devices and their configurations. Right? So now with that as background, let's switch over to our demo. All right, so what you see here is essentially the same network topology that we just looked at. So this is our web UI. So let me click on a random device in this particular network topology. Let's say I click on this and view the details. So this happens to be a Juniper device. We can see that Forward has reached out to this device, has collected the configuration from the device. But in addition to the configuration, it's also collected a lot of state tables. Things like ARP tables, MAC tables, routing tables, and so on. So Forward uses this, the data that it has collected to build a behavioral model of the network. And it uses that to provide rich contextual information to users as they query the platform.
So that is a behavioral model of the current network state as it is, correct?
Correct.
So now we have a single source of truth, that whatever you want to call it. Sorry for the marketing term. But what about modeling an intended state, or is that something you're going to get to? So we can do a diff and say, all right, what do we got to do here?
You will see demos of all of that.
Okay, so that's
the
coming.
next 2 hours.
Yeah.
Yes.
Okay, cool.
Absolutely. All right. So this is just one device that we looked at. Now let's see how we can leverage this platform to get answers to the question that the security team asked about. So we'll begin by building some situational awareness of this problem, right? So let's first look at where are the servers and IP addresses that the security team referred to. Let's begin by searching for the front-end server. So it's called app1 frontend. I see that I instantly have some results which show me information about this particular host in the network. We see that the host is connected to an ESXi switch, and we have the IP address, the VLAN, and the MAC address corresponding to this host. And this particular host happens to be in our Atlanta data center. It's connected to an access switch in the Atlanta data center. Well, what about the source IP address of the SSH traffic? Let's search for that. Well, it looks like we couldn't actually locate this particular host or this IP address in the network. So I see that there are a few pretty broad routes that are relevant to this particular IP address and some default routes, but we couldn't actually locate where is this particular host located in this network. So this matches up with what the security team had observed earlier. So this host was not actually reachable. Fortunately for us, Forward maintains a historical record of every of the snapshots from whenever it actually collected from this network. And the security incident, as the team had actually identified, was actually something that occurred on the February 5th. So we're going to navigate to the snapshot that was collected on the 5th of February. And we see that, again, this is essentially the topology map of my entire network on the 5th of February. With that, I've already eliminated a lot of guesswork from the equation. This basically states that this is the state of the network when the security incident actually occurred. Now let's search for this IP address in this particular snapshot. And I immediately get an answer showing that this is where this particular IP address was actually located in this network. So in this case, this happens to be an EC2 instance that's connected to an AWS subnet. So with that, we have the answer to our first question. So this particular IP address corresponded to an EC2 instance. It was connected to essentially a subnet that's labeled as a test subnet. It looks like someone brought up a subnet, and then the subnet and the EC2 instance were toned down since then. So that's the reason it's no longer actually reachable. But we have the state of the network as it was on the 5th of February, so we can actually reason about what was happening at that point of time. All right? So with that, let's move on to the next question that the security team asked about. We want to look for how traffic can go from the source IP address to the destination. We're going to do that by performing what we call a path search. Let's search for traffic from the IP address that we wanted to, from the source IP address of that SSH traffic. Let me take a moment to explain what you're seeing here. So on the left, we have what we call the filters panel. It shows you the characteristics of the network paths that are taken by various groups of packets that match the query that we just specified. Right? So we're not just modeling one single packet. We're giving you an answer and characterizing entire groups of packets that may be taking different behaviors through this network. Just take a quick look at one of these. So we see that there's traffic to several different L4 destination ports or different protocols, and these possibly have different behaviors through this network. What's cool about this is I can actually select one of these to refine my search. Right? So with that, I've already refined my search to just the paths that are relevant for SSH. And further, we know that we are specifically looking for traffic that actually was delivered to the application server. So let's add that as another filter to refine our search. With that, we have a single path that you see here in the second panel, the center panel here. So this is what we call as a vertical path displayer. So essentially what it has is a vertical arrangement of the hops that traffic flows through on its way from the source to the destination. So in this case, there are about 15 different hops on the way from AWS through to Atlanta. What you can do with this path displayer is you can click on a particular hop to view details about what's going on that particular hop. Why did the device make a particular forwarding decision? So we see that traffic originated in AWS, and there's an AWS routing table here, which basically has a very specific route to one particular /32 IP address, and it's forwarding traffic to the VPN gateway, which is the next hop. So the VPN gateway, in turn, has an IPsec tunnel that I see here, which is connected to our Atlanta border router. So traffic has now reached our Atlanta border router, and it's going to make its way from there to the host to the application front-end server. Let's take a look at a few other hops that are particularly relevant here. Let's take a look at this hop, which has an access control list, ACL policy that's applied. So this happens to be an ASA firewall. And what I see here in this panel here is there was some access control policy that was applied on this hop. And there was also some NAT going on this hop, and there's some L3 routing. And I immediately see here that traffic destined to on SSH traffic is basically being permitted to get through as long as it's destined to this particular destination IP. I don't need to be an expert on Cisco ASA configuration, but I have a very simple answer to the question of why this particular firewall is permitting this traffic to get through. But I can immediately click on this see device state if I'm interested to actually narrow down the specific lines of configuration that are relevant to this particular traffic. So in this case, the configuration file for this firewall is about 4,000 lines. And we've highlighted the roughly 10 lines which are actually relevant to this traffic. And we see that there's also some NAT going on this hop. So a public IP address is getting translated to a private IP address. And essentially, there's some L3 routing that's going to forward this traffic along within the Atlanta data center. Let's take a look at the other firewall along the path. So this has an ACL policy by name AWS private subnets to any. Now, if I click on the C device state, I see that this particular hop is basically allowing traffic from our AWS private subnet to always get through to the destination. So this particular firewall, it trusts all traffic that originates from our AWS VPC, and it's allowing the traffic to get through. And along the way, I can click on details for every single hop and identify how the traffic actually goes through all the way to the destination. So in this case, there's another load balancer along the way, which is basically translating this the destination IP address and load balancing to a couple of servers.
Try to understand. So this behavior modeling, actually you're reading the device configurations, and from there you are modeling how the packet will travel?
Exactly. So we're reading both the configuration as well as the state of the network when we collect it from the network.
And are you vendor agnostic?
We support a variety of vendors. If
So
that's
you
what you're
have
referring.
to, okay, so you mean you need to basically some adapters for every vendor?
Exactly. So we have basically reach out to individual devices and collect the configuration and state using commands or APIs, which are specific to that vendor. And we translate that into a vendor agnostic model internally, which could be protocol specific, and then we build an index on top of that. Right?
You support MPLS?
Absolutely.
I got a question. So this is like, to me, this looks like a fairly large network. So in this case, you're gathering state. What's the frequency in which you get the state of the network? And then how long does it take to get the state of all of those devices? Like, is it sourced from a single appliance on site and then stored there? Or does it get sourced from the cloud somewhere and stored on your cloud?
It's a good question. So there were a couple of questions there. Let me answer. Let me start with the first question. So we have customers who collect. I mean, you can configure the platform to collect periodically from the network. So we have customers who run this as often as an hour, once every hour. We have some that runs it once every day. But what's nice about this is we also have APIs to trigger these collections. Right? What that means is some of our more advanced customers, so they actually trigger collections in response to any changes they make in the network. So it doesn't have to be just scheduled collections. Right? So whenever you make any change to the network, you can trigger a collection. So that's the first part. The second part is the collector is essentially some software that you install on-premise. So your collector resides locally in your data center or within your network. It needs to be able to reach out to all the devices in your network. All of the configuration and state is collected from the individual devices and shipped either, in this case, it is shipped to the cloud, but we also have an on-prem service. So the entire application can reside in on-premise, right? In which case, it would just be local.
Now, is that just the collector, or where you actually do like calculations of path permutation, things like that? Like, so let's say you have billions and billions of objects to to run through. Where does that happen?
So we have both models. We support a cloud service where you can all of this configuration and state is shipped to the cloud, and we build the indices in the cloud. The web UI, you'd basically be accessing our service,
Right.
our cloud portal. The other alternative is you deploy the entire application on-premise. Not just the collector, but the entire processing engine as well.
Yeah, and that would be just for the efficiency of having it on site.
Well, it's two reasons. So one is the efficiency, but that's less of a reason. The more important reason is there are customers who are very security conscious.
Sure,
I mean, they have regulatory requirements that prevent them from exporting this data to the cloud.
And I have a question, and maybe you'll use an example, maybe you'll show an example, but how do you treat tunneling, right? When traffic goes through a tunnel, typically that's visualized as a point-to-point, when really there's an underlay. Do you guys sort of calculate that pathing of the underlay as well?
So we do calculate both the overlay and the underlay, but I would love to show you an example, but I'll leave you to Behram to blow your mind.
Cool, thank you.
If the customer has a robust IPAM solution, is that something that you can plug into to pull in additional information to give additional context to the diagrams?
You mean to pull in host information?
Yeah, for like if they have a robust, but just for the host as well as the network. So 10.5 is very strongly defined as it belongs to this network segment, then broken down below that, just so you're not leaving that information that they've already put together on the table.
I'm not quite sure I understood that completely.
Yeah, so we don't support integration with IPAM out of the box today. This is something that we are thinking about internally. But what the platform does support is the ability, fundamentally the ability to map specific network objects like IP addresses to names. And so that capability is available through the UI, through the API, and we can have external integrations work and define those mappings already in the system. But a direct integration with IPAM is not present out of the box today. But that's something that we can think about.
Okay.
In this view here, when security has asked you this question and outlined this path, how do you give them this information? Do you just give them the link? Do
You share the link.
Export it?
You can share the link. You can also export this. So there are APIs as well as we have export of data in different forms. So in this case, you would just share the link or the query.
Gotcha.
Can you trigger the trace based on fiber cut in the network? So there is an incident because the fiber cut will change the paths immediately. So can you trigger it?
So there are APIs that we expose to trigger collections, but essentially you would have to detect the fiber cut event and trigger this through APIs. That's possible. Yeah. Okay, so with that, we have our answer to the second question. So we didn't have to comb through lots and lots of configuration files. I didn't need to be an expert on Cisco and various platforms, the configurations, but I have my answer as to how to get through from the source to the destination.
There's a question on Twitter from Brandon asking about how the actual configuration and the operational statistics are collected.
For most devices, it's through SSH. There are a few platforms for which it is through APIs. For example, for cloud, for AWS, we would collect it through APIs. Similarly for vCenter and so on. For the devices that do support APIs, we use them directly. Okay, so let's move on to the third question. So the third question was, what are the other servers that an attacker could have gone through with SSH from the front-end server? So let's search for traffic from the front-end server. We specifically care about SSH traffic. And further, we don't care about traffic that's actually getting dropped, denied, or black holed within the network. We only care about traffic that's actually getting delivered. And in particular, we don't care about traffic that's actually destined to the network devices themselves. So they have their own SSH credentials. We care about traffic that's going out to the servers in the network. So the way we're going to do that is by essentially specifying another filter which excludes traffic that's actually getting received by any interfaces within the network. So this is a handy alias that I just defined. It basically says anything that's like a self port or a loopback interface on a device where the device itself would consume the traffic. I'm excluding that. So with this, what I see is all of this traffic, all the SSH traffic from the front-end server is localized to the Atlanta data center. In fact, it's just a few racks, top-of-rack switches in the Atlanta data center. It's just a few racks of servers that might be potentially involved, that the security team would have to further inspect. But further, I have a very simple answer to the set of IP addresses that are actually involved. So recall that I mentioned that these filters show you groups of packets that match the query. Right? So this is the exact set of IP addresses or subnets to which an attacker can SSH from the front-end server. So with that, I also have the answer to my third question. Let's switch back to our presentation. So here are the questions that the security team asked. So we've identified that the source IP address was a specific AWS instance. We've identified not just the fact that there were two specific firewalls along the path, we've also identified why these firewalls were permitting traffic. They were permitting both SSH as well as HTTPS traffic to get through. And further, we've also identified the set of other IP addresses that the attacker could have logged into from the SSH, from the application front-end server. So that's great. So this is an operation that could have easily taken me all of Monday or the whole week. But I've just managed to solve this entire problem. I've solved my first ticket. It's just 9:30 on Monday, and I've already solved my first ticket using forward networks. So this is exciting. I can do so much more today. So to summarize, so how do I get access to instant information with rich contextual information about the network? I can use forwards path analysis and search. I don't just have instant access to a lot of data. The data is transformed into a behavioral model that provides contextual information in a concise and understandable in an understandable form. So this is what is really important for users to solve issues quickly and get quick answers to questions they have about the network. And how do I analyze and understand network behavior at any point of time? For that, we have historical snapshots provided by Forward Networks. So the network is automatically documented by Forward Enterprise. We have a historical record of not just the network topology or the configuration files, but the actual forwarding behavior of the entire network at different points of time. So at Forward, this is what we call as the other SDN, self-documenting networks. With that, I'm going to hand over the reins to our next speaker, Andy, who's going to walk us through what happens on Tuesday.
I ask you a quick question about the AWS. Is there a way to pull the security groups that are associated with that host? Because as security starts to increase in AWS, security groups assigned to services become more and more important.
Absolutely. We pull in all of that information, including about security groups. So if we go back to the search here. So these are the security policies that are being applied to this particular traffic right there.
So will you be talking about any other use case, or security is your main focus?
We're going to be covering 5 different use cases today. Yeah.
Do you have any sort of a simplified UI so you can like partition it and give a version to a certain group within your network division to have them say, like, for example, your use case, give them to the firewall guys and let them simulate an SSH session?
Absolutely. So we have what we call a quick path search, which simplifies how you actually, you don't need to look at our query syntax, which is already pretty simple, but you can just specify the source and the protocol and the destination IP address. You can get the same kind of answers. We also have users who've built like Slack integrations to just show the relevant hops. Like it's similar to a trace route, but more advanced. It shows you what are the hops, why something is blocking traffic, why something is permitting traffic. You also get answers about multiple paths, not just one single path.
So when you refer to the multiple paths, if you're using this and you hit something like a Cisco router with multiple VRFs with the same network or a prefix, like what would that look like? Would it give you, would it drill down to that information?
Absolutely. So it's going to show you, well, one is, so each of these paths that you see here is really a path group. So one of the examples here that you see is, so this is an ISP edge switch, edge router. And you see that there's some ECMP that's going on or some multipathing that's going on. So you can select this alternate path, and you can see that the traffic just got rerouted to take an extra hop. Right? So we compress the information as much as possible when traffic follows the same behavior through the network, even though there are multiple paths. And if there are multiple behaviors, we would segregate those.
Roel, correct me if I'm wrong, but I think the question you may be asking is if you're searching for an IP address that exists in 2 separate customer VRFs,
Yeah, there could be.
how does it identify which one? Is there a way to?
Oh yeah, absolutely. So I'm not sure I have an example in this particular snapshot, but
You'd be
essentially
able to distinguish.
we would locate the IP address at 2 different points and ask you which one you're actually care
kind
about.
of in that same view. It's just
Absolutely.
still
Yeah, you would just search for the IP address directly, and just like we got one single host for that IP address, you'll see multiple results.